Good morning to all of you. My name is Vishal Jayaswal, Assistant Professor, Department of Computer Science, Ajay Kumar Garg, Engineering College, Ghaziabad. Here I am going to take lecture on computer organization and architecture, and my current topic is going to be execution of complete instruction. Basically, in this topic, we are going to discuss how the instructions are executed in the processor, and we required some registers, some ALU, and instruction decoding circuit, etc. In this topic, we are going to cover, here we are going to discuss topic basic processing unit. Then after, we are going to discuss the single bus organization, that is the architecture of processor. Then we are going to discuss register transfer, basically the input output gating, how to input output gating is discussed in this topic, that is register transfer. And after that, we are going to discuss the MDR, that is memory data register control signals, how memory data registers control signals are. Then we are going to discuss fetching a word from memory, how to extract a word from memory. Then our topic is storing a word into memory. That means in fetching a word from memory, it means we are going to read, and if we are storing a word into memory, it means that is a write operation. Then finally, we take some example by which we are going to discuss the complete instruction for add R3 in braces, R1. First, the basic processing unit. Suppose that each instruction comprises 4 bytes and memory is byte addressable. This is the important concept for this. We are going to take instructions of size 4 byte and memory is byte addressable. To execute an instruction, the processor has to perform the following steps. First one is fetch, then we increment the value of PC by PC plus 4, then carry out the actions specified by the instruction. And if we talk about the first 2 steps, step number 1 and 2, these are called the fetch phase, and step 3rd is referred to as execution phase. Here the important concept is our instruction comprises 4 bytes and memory is byte addressable. This is the diagram of single bus organization. Here we are going to take one internal processor bus that is on the processor. All the data is transferred through this internal processor bus, and these are the registers PC, MAR, MDR, IR, R0 to Rn-1, and temporary register, and Z register and Y register. These are the registers, and here is a multiplexer is used, and this is the ALU. This is the ALU. This is the architecture of processor. First, the processing is start from the fetching a instruction from memory, and the address of the instruction is placed in the program counter register. Basically, PC holds address of next instruction. PC holds address of next instruction. So our instruction address of the instruction is in the PC. First, we have to if we want to execute some instruction, first we extract the instruction from the memory. The operation is performed on the 3 steps. First one is fetch the instruction, then decode the instruction, and third step is execute the instruction. If we talk about the fetch phase, our address of the instruction is placed on the program counter register. First address is out by the control signal PC out. First we use PC out control signal, by which the value of the program counter register is go on the internal processor bus, and we are going to fetch instruction from memory, and memory on this side, here we can say this is the memory. So if we use the control signal PC out, the content of the program counter register go on the internal processor bus, and we receive the program counter register value on the MAR. So we are going to use MAR, that is memory address register in. We are going to use MAR in, by which the value of the program counter register that is going to the internal processor bus, that is received on the memory address register. Then we are going to take control signal. This is the basically this is the control unit, and the control signal that is of read, that is generated by the control unit and going to the memory. So the read command issued from the control unit to the main memory, that is, and here we are already placed the value of the instruction address of the instruction on MAR, by which the instruction is read from the memory and going to the MDR register, that is memory data register, and after that MDR after that the instruction goes to the internal processor bus, and then this goes on the instruction register, that is IR. Then the fetch phase is complete. First we have to place the program counter register value on the internal processor bus, then we receive the program counter value on the MAR register, that is memory address register. Then we issue the read control signal to the memory. So which value that is placed on the memory address register, that's corresponding instruction that is read out from the memory and go to the MDR register. Then then instruction is go on the internal processor bus, then that is received on the instruction register. In this way we are going to perform the fetch phase. After that decoding is performed, and this is the instruction decoder and control logic that is going to read the instructions that are present in the instruction register and generate the control signal accordingly. This is the fetch phase. Here we are going to take Y register, that is also called temporary register, and this is the Z register. Here we are going to take constant 4. If we want to increment the program counter value, and we already say that our instruction is of 4 byte and memory is byte addressable. So if we want to increment the value of program counter, then we can say that PC tends to PC plus 4. If we want to increment the value of PC, then we have to perform PC plus 4 in the PC. It means we have to add the constant value 4 in the program counter value. So if we want to do this, we have to out the content of the PC and receive on the B input of the ALU. We have to PC out, then PC out, it means the value of the PC is on the internal processor bus, then this is automatically received on the B input of the ALU. Here we are going to select, we have to select 4 or select Y. Here there is a 2 options, we may be select 4 or select Y. In here in this scenario we have to add the 4 into the PC value, so we have to select 4. So if we use select 4, then the 4 value input to the ALU input A. So here is the PC and here is the 4. Then we have to perform the add operation. The control unit issue the add control signal to the ALU. So PC, one operand is PC and other operand is 4, and read control signal is add. It means PC plus 4 is performed and stored in the Z register. And if we out the value of the Z on the internal processor bus, it means PC plus 4 is on the internal processor bus, and if we want to receive in program counter register, we allow by the PC in. So in this way we can increment the value of PC by PC plus 4. So in this way we are going to fetch the instruction from the memory, and how to increment the value of the program counter register, and how to increment the value of the program counter register. Then last step is execute the instruction. In single bus organization, there is a one disadvantage, that is only one data word can be transferred over the bus in a single clock cycle. And if we talk about the solutions, provide multiple internal pass, and multiple pass allows several data transfer to take place in parallel. This is the diagram of register transfers, that is also called input output gating of registers. Basically here the control, basically there is a switch that is defined on the registers place. Here this is the RI register, and we have uses the two switch, that is RI in and RI out. If we want to place the content from the internal processor bus to the RI register, if you want to place the content from the internal processor bus to RI register, then we have to select the value of RI in equal to 1. If the RI in equal to 1, then the content of the internal processor bus go into the RI register. If we want to out the content of RI into the internal processor bus, then the RI out value should be 1. If the value of RI out is 1, then the content of RI register go into the internal processor bus. This is the basic example for register, that is, this is apply to all the registers that is mentioned in the previous diagram, that is single bus organization. Here we are going to use another switch for Y register, that is Y in. If the Y in value, that is Y in value equal to 1, it means the content of the internal processor bus go into the Y register. And we can see that the what content we are placing on the internal processor bus, that is automatically go into the B input of the ALU. There is no switch for B input of ALU. We can say that what value we are placing on the internal processor bus, that is already by default that is going to the B input of the ALU. Here we are going to use select lines, and this is a multiplexer, either select 4 or select Y. What value we select, that is if you select 4, then if you select 4, then the value of 4 is going to the A input of the ALU. If we select Y, the value of the Y, the content of the Y register is going to the A input of the ALU. So we can select either 4 or select Y. Here we are using another switch for Z register. It means if the value of Z in equal to 1, then the operation that is performed on the ALU going to the Z register. If the value of Z in equal to 1, if the value of Z out equal to 1, it means the value of the Z register is going to the internal processor bus. This is the input output gating for the register transfer. Basically, these are the switch that is applied on the each register that is mentioned in the single bus organization. This is the control signals for MDR register. Basically, this is the memory data register, and here we are going to use 4 switches, 2 switches at the side of memory, that is MDR out E and MDR in E. These are the 2 switches, and 2 switches on the internal processor bus side, means MDR out and MDR in. These basically 4 switches are used in MDR register. If we want to fetching a word from memory, so we have to take an example, that is move R1 in braces comma R2. It means we are going to take address of R1, content R1. Address is the content of R1 and value is the R2. It means we have to fetch the content of R1 from the main memory and places it into the R2 register, for which we can take the first step, R1 out, MAR in and read. These are the 3 control signals that is used in first micro operation, first micro instruction. So for fetching, we are going to use R1 out, MAR in and read. R1 out, MAR in and read. Means the content of R1, it means here we can say that this is R1 and the content of R1 is out and go on to the internal processor bus. Then this is received in the MAR register, that is memory address register. Then this is received on the memory address register. Then after that, the control unit issue the read control signal to the main memory, by which let's suppose the value of R1 is 100 and let's assume this is the main memory. This is the main memory, and here there is the location of 100, and suppose this is the instruction. This is the value or data. So the value of MAR, currently the value of MAR is 100 because R1 is out and MAR in is 100. So value of 100 and corresponding value, suppose let's value of at address 100, the value is 50. Then 50 is fetched and go into the MDR register, means value of MDR is 50, and this will go onto the R2 register. Here we can say this is the R2 register, and this 50 value is received into the R2 register. So first step is R1 out, MAR in and read, and second step is MDR in E WMFC. Basically we are going to perform the memory operation. So we don't know that memory operation performed in at what clock cycle and how many clock cycle are used in for memory operation. So we are going to use WMFC signal, means wait for memory function completed, and MDR in E switch is enable, means if the value of the content is read from the memory, so the gating, that is MDR in E switch, should be enabled so that the value is to be read from the memory and go into the MDR register. When WMC means if we can say that memory function is completed, then MDR out and R2 in, means we are going to fetch a word from memory. So MDR out means the content of MDR is going to the internal processor bus, and the R2 in means the content of the content that is placed on the internal processor bus is going to the R2 register. Next is storing a word in memory, by which we can take another example, that is move R2, R1 in braces. Here we are going to use R1 address R1 as a address and data, that is R2, and we are going to write the content of address of the R1 and data of the R2 in the main memory. For this we are going to first perform the first step, that is R1 out, MAR in, means the content of R1 is the address of the main memory, that is out. It means the R1 content of R1 is go on the internal processor bus. Then MAR in means memory address register received the content of R1. Then after that, second step is R2 out, MDR in and write. The data is a R2. It means we R2 out means we places the content of R2 onto the internal processor bus. Then this is received on the MDR register, means memory data register, and we issue the write command to the main memory. And third step is MDR out E. MDR out E means our content of R2 should go into the main memory, and WMFC, it means we issue and write command to the main memory. So, we have to wait for the memory function completed. So, we are going to use WMFC signal, means wait for memory function completed. If we can say memory function is completed, means write operation is performed. This is the complete instruction for add R3 braces, R1. This is the basic complete instruction for which we are going to take this topic. First three steps are used for the fetching of instruction from memory. Basically, first three steps are fetch instruction from memory. After that, from the step number 4 is used for execution. So, if we add R3 in braces, R1, it means we are going to perform this operation. R1 plus M of R3 means the content of R3 is the address of the main memory. We have to go into the main memory and address corresponding to the R3 we have to fetch from the main memory and take onto the processor and add into the R1 register. Then content is placed in the R1 register. So, for doing this task, we have to perform first 3 phase, that is called fetch phase. We have to PC out, first micro operation and first step, that is PC out. Then it means content of the program counter register is go into the internal processor bus. Then it is received on the MAR register, that is memory address register. Then we issue the read command because we have to read the instructions from the main memory. So, we are going to issue the read command. Then we are going to select 4. We are going to take select 4 because we have to increment the value by PC by 4. We have to perform PC plus 4. So, we are going to select 4. Add means perform PC plus 4. Then we have to store the value of PC plus 4 in Z register. For storing the value in Z register, we have to use Z in control signal. Second step is Z out. It means the value of PC plus 4 is out from the Z register and go into the internal processor bus. Then this is PC in. It means the value of PC plus 4 go into the internal processor, go into the program counter register. This is the Y in. We are sending the value of PC plus 4 in PC and Y both, because here we are placing the value of PC plus 4 in Y, because if instruction is branch instruction, then we are going to use this value, that is Y. We are issuing in step number 1, that is read command. So, in step number 2, we have to mention WMFC control signal, means wait for memory function completed, because we are going to read the instruction from the memory and we already issue the read command. So, if we say that memory function is complete. So our instruction is fetched from the main memory and go into the MDR register. So step number 3 is MDR out, means our instruction is out from the memory data register and go into the internal processor bus. Then IR in means our instruction is go from the internal processor bus to the instruction register. This is the fetch phase for the instruction. After that, we can see our what operation, what execution we have to perform. We have to perform R1 tends to R1 plus M of R3. Means we have to go onto the main memory for fetching a content corresponding to the R3 register. Then we have to add into the R1 register and places the content, final content in the R1 register. So for this, we are going to R3 out first using the control signal, that is R3 out, means the content of the R3 register go into the internal processor bus. We are receiving this content on the memory address register. So we are going to use memory address register control signal MAR in. Then we have to read from the main memory. So we are going to issue a read control signal. Then step number 5, we are going to use R1 out, because we have to add content of R1 into M of R3. So we are using control signal R1 out and placing this content into the Y register. So R1 out, then Y in. We are issuing in step number 4 read command for the memory. So we are going to use WMFC control signal into the step number 5. If we say that function of memory is completed, then the content of R3, address of the R3 that is corresponding to the data is fetched from the main memory and go into the MDR register. So step number 6, we are using MDR out control signal and select Y. If we select Y, the content of Y register, the content of R1 register that is placed in the Y, that is selected and go into the input of ALU, A input of the ALU. MDR out means the content of R3 that is taken from the main memory is out and go into the B input of the ALU. And add means this operation is performed and places the content in Z in register, means the R1 plus M of R3 is added and places in the Z register by the Z in control signal. Then finally Z out means this addition should out from the Z register and finally places on the R1 register. Then end. This is the complete execution of the instruction in the processor. Okay, thank you. In next lecture, we are going to take some other example on the execution of the complete instruction. Thank you.